The question we are solving now belongs to test series 2. It is of network theory. In specific, it belongs to DC network solution methodology. As per the question, there is a network which is given as shown. It contains a 1 ampere current source in series with a 1 ohm resistance and a 2 ohm resistance which is connected in parallel with this combination. So this node is marked as 1 and the nodes 1 and 2 are connected by a 2 ohm resistance. Node 2 is connected to ground by using a 1 ohm resistance and node 2 is connected to ground using another 2 ampere current source as well. In this problem, we need to find the potentials at the nodes 1 and 2, that is V1 and V2 in volts. By applying nodal analysis at the node 1 and 2, we see that nodal analysis can equivalently be obtained from KCL. Hence, by nodal analysis at node 1, we see that V1 by 2 plus V1 minus V2 by 2 minus 1 is equal to 0. That is, by calculating the currents through each of the branches and by using the KCL theorem, we can write that V1 by 2 plus V1 minus V2 by 2 minus 1 is equal to 0. This upon simplification becomes 2V1 minus V2 is equal to 2. Similarly, by applying nodal analysis at node 2, we see that V2 plus V2 minus V1 by 2 minus 2 is equal to 0. This is by applying the KCL at the node 2 or equivalently by applying the nodal analysis at node 2. So this upon simplification becomes minus V1 plus 3V2 is equal to 4. So upon simplifying these two equations, we see that 2V1 minus V2 is equal to 2, and by multiplying the second equation by 2, we see that minus 2V1 plus 6V2 is equal to 8. So that implies upon adding these two equations, 5V2 is equal to 10, hence V2 is equal to 5 volts. So V2 is equal to 2 volts. So upon substituting V2 equal to 2 volts in the first equation, we see that V1 can be written as 2 volts. From this we see that the potentials at the node 1 and 2 are V1 is equal to 2 volts and V2 is equal to 2 volts. Hence, the correct option representing the node voltages is A.